Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range. This is standard A.6A in the great state of Texas, and we are using item number 5 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we need a function that has a range where all real numbers, so range is going to be our dependent variable, all real numbers greater than or equal to -1. So we're looking for a quadratic here, because if you take a look, right, each of these have a squared, which means that's my highest degree. So we're going to look at a parabola shape. And so what I'm looking for is I'm looking for something that's got, and I don't know whether it's offset or not, but let's just kind of sketch it here. It's going to be facing upward. It's going to kind of go like this, and it's going to have a minimum there at -1. And then it's going to kind of move upward. That's what I'm looking for. So if we want to, we could graph all of these, but we can actually do this without the graph. If we take a look at our reference materials, we are going to see that we actually have a vertex form in our quadratic equation. And so I'm going to write this for us right here. It's going to be f of x equals a x minus h squared plus k. If we can get our equations to look like that, then our vertex is going to be 8k. And that's going to be something that's going to be important for us for years to come, even up in Algebra 2, whether we deal with exponentials or whatever. And so let's look at this h and k, and how can we form each of these equations into that? Because we actually already have. You know what? Let's deal with c and d, because they're already in that vertex form. So let's look at C. It's x minus h. So really what this needs to be is x minus -3, if that's going to give me a +3, plus 1. So my h is going to be -3, and my y is going to be 1. So I'm not necessarily worried about the x value. I'm worried about the y value. So it needs to have, it's positive, so it's opening up, but it's going to have something that kind of looks like this. So -3, 1 like this. That's my -3. And there's my 1. And so it is opening up, but it's opening up at -1 as your minimum, or at 1 as your minimum rather than -1. So this one is going to be the same thing. So this is going to be x minus -4 in order to get that +4 inside there, squared minus 17. So my h is going to be -4, and then my y is going to be -17. So that's going to be really off. So -4, -17. It is a positive on the outside, which means it's moving up, but it's going to be something kind of like this. So that's not going to work. It is opening up, but it's not going to work. So if we look at A actually is in vertex form. It just doesn't have a B value, right? So if we think of ax squared plus bx plus c, what we have is -x squared. So my a is -1, my b is 0, and then my c is that -1 right there. So what we do is we complete the square. So we take half of our b value and then we square it is what we do. And we add that to both sides. Well, that just ends up being 0, right? So it's going to be negative, and then I'll put x minus 0 squared, right? If we want to get that in there as a complete the square, and then a -1. So what we end up doing here is we end up having an x value of 0, y value of -1, which is good. We want that -1, but look, it has a leading negative, which means it is actually going to be right where we want it to, but it's going to open down because it's got that leading negative. So what we're looking for is this b here, and let me complete the square for us. So if I complete the square by halving and then squaring that b term, I'm going to end up with this right here. So I have an h of 2 and a k of -1. And so that's opening up because it's positive. That's what we're looking at. So our answer here is B.